So all that is being said is that the period of oscillation depends on the mass. Okay, the period of oscillation also depends on the length. The period of oscillation also depends on gravity. Okay, and these are all kind of relationships that are directly proportional. And when quantities, as I said before, when quantities are directly proportional, an increase in one results in an increase in the other, and vice versa. So we can connect, put all the three together. T is directly proportional to M, T is directly proportional to L, and T is directly proportional to gravity. Okay, because the relationship for all the three are direct proportionality. We have a direct proportionality. In variation, whenever you introduce an equal to sign in place of this proportional sign, there should be a constant of proportionality. So once we introduce an equal to make it to have an equation, there should be a constant of proportionality k, and the constant is any chosen variable of your choice. But I am coincidentally choosing the letter k. So k times m times l times g, and I have k because I'm introducing an equal to sign to form the equation. Please, are we okay?
No, please. Please, I don't understand the part that started with a K.
Yes.
This
No, please. You don't understand anything.
this explains that all the three variables, mass, length, and gravity, okay, all depend directly on the period. Okay, hence this direct proportionality or proportionality sign. Now, in variation, under this concept, okay, whenever you introduce an equal to sign in place of this symbol, okay, this symbol, whenever you introduce an equal to, there should be a constant of proportionality. Okay, so my k, the k is equal to the constant of proportionality as a result of introducing what? This is coming in as a result of introducing
The equal to.
The equal to sign.
So k comes in as a result of introducing the equal to sign. Equal to sign. So whenever you eliminate this symbol and introduce an equal to, there must be a constant of proportionality. And this constant of proportionality is just a variable. You can choose any letter of your choice. But incidentally, most often we use K or C. We use either K or C. So it has sort of become a norm. Is that okay?
Yes.
All right.
Yes.
Okay. All right. So C is equal to that. Now, the other method is that we don't know the exponential value of this independent quantity. Oh, this is independent. This is dependent. So what I mean is that MLG depends. Okay, M for M, L, and G, T will depend on them. So we call this as independent variable, whereas t is a dependent variable. Okay, we don't know their exponential value, so let's represent them by letters. It can be x, y, and z. The k is not affected because usually the k is dimensionless. It wouldn't have any dimension. So because we don't know the exponential value of the independent variables m, l, and g, let's represent them by the letter x, y, and z. So k m to the power x, l to the power y, and g to the power z. All right. The next method is that substitute the dimensions of all of them. M, we are told, is mass. L, we are told, is length. G, we are told, is gravity. And T is time. So substitute the dimensions of all of them. So this is capital T is equal to K. K is a constant. Then the dimension of M is mass, capital M, raised to the power X. The dimension of the length is capital L, raised to the power Y. The dimension of gravity, okay, acceleration due to gravity is L T to the power negative 2.
2.
L T to the power negative 2. So let's expand what we have at the right hand side. This is single, M is single among all the letters. So M raised to the power X. For L, we have Ly and another L to the power Z. T is also singular at the right hand side. So minus 2Z. So we have K M to the power X, L to the power Y plus Z, T to the power negative 2Z. Are we okay? Now, when you compare, you equate counterpart of C at the left hand side to the counterpart of C at the right hand side. So we have T being equal to T to the power negative 2Z. So we can deduce from this comparison that minus 2Z, which is equal to 1. Therefore, Z is equal to negative 1 over 2. Are we okay here? Are we okay with Z?
No, please.
So, after expanding all this, substituting the dimensions and expanding, all that we are doing is that we want to equate equal counterparts or 10 at both left and right. So you look at the left hand side equation and then equate whatever is here to its counterpart. T to the power 1, we also have T to the power negative 2Z. So that's what we've done. Okay. This is T, meaning this carries the power of 1. So we equate the powers, same basis. So we are equating the exponent. So negative 2Z is equal to 1. Are we okay? Therefore, you go ahead to find the value of Z by dividing 2 by 2. And that gives the Z value to be equal to negative 1 over 2. Okay?
Yes, please.
Mr.
Then, Are you asking a question?
Yes, please. Please, what
Okay,
about
go
the
ahead.
one with, please, what about the one raised to the power y plus z? What will you do to that one?
We
And
are
the m raised to the power is,
we are going to continue. Don't worry.
okay, thank
We compare the other dimensions too. We've done that for T. We do that for L. We have L to the power y plus z equal to what will be its counterpart at the other end? What will be?
Zero.
So this is L to the power 0. Okay. Because L to the power 0 is actually 1. And so we could deduce from here that y plus z is equal to 0. But once we have z, we can easily find y, isn't it? Isn't it?
Yes, please.
Yes, please.
What do you think will be y? What do you think will be the value of y?
Negative half.
Positive half. Good. So we found that y. We are left with x to go. So let's look at how we can find x2. M to the power x will be equal to m to the power x will be equal to, I'm waiting.
M
m to the
raised
power
to
0.
The power 0.
Good. M to the power 0. Therefore, x is equal to 0. So you see, we found the exponent or the powers of each quantity. Okay, each independent quantity. So let's substitute. Let's substitute whatever we had for x, y, and z. Can I clean this side of the board? The left hand side. Can I clean it?
Yes, please.
Okay. So let's substitute it here. We have t is equal to, so t is equal to k m to the power 0 because x is 0. L to the power half because L is to the power y, so half. And g to the power negative half. Okay, this can be regrouped, meaning m will be deleted from the equation because it's to the power 0, and so that's equal to 1. So L to the power half can be expressed as the square root of L. Now in indices, if you have g to the power negative half, this is equal to 1 over g to the power half. I hope you understand that.
Yeah.
Good. And so what it means is that j to the power negative half can also be written as, so let me be systematic. L to the power half over j to the power half, and L to the power half is equal to square root of L over j to the power half square root of j. Okay, so finally we can express a whole value as k to the root of L over g. Therefore, the period of oscillation, capital T, is equal to the constant of proportionality, times the square root of L on G would be the equation between uh, the quantities M, L, and G. Now, this constant of proportionality K is equal to 2 pi. And I'm giving you this because I'm familiar with the equation. It's my own equation. So if you put that in, you have T being equal to 2 pi times the square root of L over G. And this is the mathematical equation you were using in your change of subject at GHS. Okay?
Yes.
Yes, please.
Yes.
Okay. It's not so lengthy, but you just would have to understand first one. Okay, after the lesson, please, you have to whenever you are free, go through it once more. When you miss out on something, the video is there to guide you. Go and then watch my video, subscribe, and pass your comment, and it would help in your revision. Okay. Okay, let me give you a quick one to try. An easy one, of course. Hello.
Mr. Ada, please, why did you equate K to 2 pi?
Yes, because I know this constant. I know this equation. As I said, it is my own equation. Equation in physics connecting period of oscillation of a simple pendulum to the length of the string and gravity. So I know the constant of proportionality K is equal to 2 pi. So I know because that's why I substituted that there. Okay.
So please, okay, so please, if we are the ones working and we didn't know, can we end that
you,
scale?
you won't be penalized if you don't bring 2 pi.
Okay, thank you.
Because you don't know. Okay.
Yes, please.
Sometimes the best we can do for you is that we give you in a question that take K to be equal to 2 pi. And with that, we expect you to substitute 2 pi for K at the end of the whole process, right?
Yes, please.
All right. Okay, a quick word. You see the short I just sent you. I gave you two different questions. The second question is about, okay, let me go and look at it and then let me also read to draw your attention. It said, the energy E of a photon depends on the mass m and velocity of light c. The energy E of a photon depends on mass m and velocity of light c. Form an expression connecting the quantities using dimensional analysis. Form an expression connecting them. The them refers to E, M, and C. Form an expression connecting them using dimensional analysis. Please, I'm sure you have seen the question. I posted it on our page.
Yes, please.
All right, start with. This is the problem of the day. I'm giving you 5 minutes to do this and then give me a feedback. Okay. Whilst I also go for commercial break. Mhm. Okay, thanks for finishing on time. What did you get? Mhm. Yaba, what did you get? Mhm.
E is equal to MC squared.
E is equal to Yaba. Hello.
KMC squared.
E is equal to MC squared. This is a powerful equation in physics. We call this equation as Einstein's mass energy equation. Einstein's mass energy equation, named after Albert Einstein. Okay, so if you got E is equal to MC squared, in fact, you can be smiling to the bank. You are more than correct. Let me see by hand those of you who got that. If you got E is equal to MC squared. Samantha, okay, more hands. 5 hands, 6 hands. Oh, okay. Uh-huh. Okay. Good. Good. Please, if you have a challenge with this question, let me know so that we can go through it quickly. If you got any challenge in working it. Nobody had an issue. Lauren, okay, let's quickly go through. We have about 3 minutes. Let's quickly do that. That the energy E of a photon depends on the mass and velocity of light c. So E is directly proportional to mass and velocity of light c. So E is equal to a constant of proportionality, okay? M unknown, C unknown. Now, what's the dimension of energy? What's the dimension of energy? First times distance. So M L T to the power negative 2 times L. So M L squared T to the power negative 2 squared. Okay. This is K M X. This is C. And C we are told is velocity. So L T to the power negative 1 Y. When we expand this is what we have. Ly T to the power negative Y. So when you compare the left hand side to the right hand side, M is equal to M to the power X. Therefore, X is equal to 1. L squared is equal to Ly. Therefore, Y is equal to 2. Then T to the power negative 2 is equal to T to the power negative Y. And T is equal to, Y is equal to 2. Okay. Oh, we are talking about X and Y. So if I have X, well, from another Y. Oh, okay. Okay, it's the same thing. It's the same thing. So let's put our values into the equation. When we substitute X and Y into the equation, we have E is equal to K M is to the power 1. X is to the power, X is 1. Then C, Y is equal to 2. So 2. When we put them together, we have KMC squared. And here, when you consider the SI units of energy, mass, this, okay, you have the constant of proportionality to be equal to 1. Therefore, E is equal to MC squared, giving us the famous Einstein mass energy equation. So those of you who couldn't figure it out, please, this is it. This is it. Any question? No question. So this is where we bring our meeting today with it, for the whole week to a very good end. Please, I'll send you questions on the platform. Do it, take a shot, and get it back to me. This time, I would increase the level of difficulty of the question to see how you can apply what we've done for the day. Until we meet again next week. In fact, bye-bye to all of you. And please, subscribe.
Bye.
Go to the platform and
Bye.
subscribe. Pass a very good comment.
Bye.
Bye. Bye.
Okay. Hello. Okay. All right. So
Please,
Yeah.
the first one. Okay, we had 2 pi. So how did we get 1 for this one?
oh, you see, I told you I gave you k to be 2 pi because I know the formula or the equation. And here, and so that's why I substituted the constant. It's a non-dimensional constant, which I know is equal to 2 pi. Here, k is equal to 1 because I know the equation is actually E is equal to MC squared. But you can get k to be equal to 1 when you consider the SI units of all the quantities in there. Is that okay? So I'm telling you this because I know what the equation is. That is why. But if you present your final answer as E is equal to KMC squared, you won't be punished for doing that. That's the correct thing you are doing. Are you okay? It's gone. Okay, Galaxy, J4. We have closed though. Okay, Galaxy, quickly ask your question.
Mr. Edia,
Hello.
please, what's the SI unit for velocity?
Oh, meter per second.
Okay.
LT to the power -1. So meter per second.
And please, and what about acceleration?
Meter per second squared. LT to the power -2. The dimension.
That's the SI unit.
The SI unit is meter per second. The dimension is LT to the power -2.
Okay, so it's the same as
Knowing the dimension, you can easily deduce the SI unit.
okay.
Yes. So don't forget, we use dimensional analysis to deduce the SI unit of quantity.
Okay, I understand. Thank you very much.
Bye bye.